Mic testing, mic testing. Alright, we're live, we're live. Okay. So today, what are we going to be doing in this live? As you guys could see by the title and thumbnail, I'm going to be learning about inheritance and object-oriented programming, or inheritance in Python. So let's get to my gameplay screen, or like my display. Just check if I'm audible. Okay, and let me know if like the music is way too overpowering. Honestly, I might just check that real quick because I did add a few changes to my music's volume, so let me just check if it's too overpowering. Give me a second, guys. Alright, give me a quick second. Let me just check if it's too overpowering. Honestly, might have to decrease the volume a little. Okay, how's this? Maybe a bit lower. Okay, this should be good. Alright, this should be perfect. Okay, so let's go up and say Sensei, I'm live. And guys, let me know if the music is still too overpowering. I can like decrease it a little. Okay, there we go. Okay, listen up, chat. Listen up, chat and Vivek. The training grounds are open. Today we're diving into inheritance, the power that lets one class steal. I mean, reuse another class's code. Okay, by the time we're done, Vivek will be able to build entire Python dynasties where child classes take after their parent, their parents, but still rebel when they want to. And guys, I'm not warmed up yet, so ignore me if I can't read properly. Or Vivek, grab your mental katana. Let's start with the ground zero explanation so our viewers know exactly what's happening before we swing into broken code drills. You ready for me to break it down from scratch? Let me say, ready, sensei. Okay, alright, listen close. Vivek and chat, pay attention too. Inheritance is like genetics for code. You have a parent class, also called superclass, that contains variables and methods, okay? Then you have a child class, also called the subclass that can, let me actually decrease the volume from here. Okay, perfect. Okay, that can inherit everything from your parents so you don't rewrite code, okay? Add new features, okay, that parent never had, or existing features to change behavior. I see. Basic example, the family tree. So we have an animal class, that's the parent class. We have a instructor with defined under in it with a parameter of name, self.name equals name, define speak. Okay, so return an f string self.name, so my name makes a sound. Class dog. Okay, so this is a child class. Oh, so I gotta add my animal class as the parameter to my dog class, so they inherit everything here. Okay, define speak, overriding speak method. Okay, return an f string barks. Rex equals dog Rex. Okay, print rex.speak, Rex barks. Oh, I see. Dog inherited the dunder init method from animal, so we didn't have to rewrite it, but dog overrode speak to change the behavior. Okay, so the speak was makes a sound. Here it barks. Okay. Why this matters? Without inheritance, you copy paste the same code across multiple classes. That's sloppy. With inheritance, you write code once, reuse it everywhere, and make changes in one place. Oh, so basically, if I like make changes in my parent class, the child class or the child classes gets that change as well. Okay, key points before we drill. Super. Lets you call the parent's version of a method from the child. Okay, lets you call the parent's version of a method from the child. I see. A child can have its own variables / methods that the parent doesn't know about. Oh, I see. Okay. Inheritance chains can be multiple levels deep. A child can inherit from a parent who also inherited from another class. Now, since you're live, here's the plan. I'll throw you 5 broken inheritance codes one at a time to fix your warm-up, okay? Then we'll do instruction-based coding until you blend inheritance to your will. You ready for the broken code number 1? Okay, this is going to be sneaky. Let me say, ready, sensei. Alright, maybe drink some water as well. Okay, here comes broken code number 1, Vivek. Don't screw this up or I'll make you rewrite it until your fingers bleed. Okay, so we have a class called vehicle, or like vehicle. We have a dunder init method, make and model. Okay, 2 parameters. We created 2 instance variables, self.make equals make, self.model equals model. And then we have a child class called car with the index of our class method. Okay. Define dunder init self make model year. Okay, self.year equals year. Okay, so we can access our make and model from here. We just need a year. Okay, honestly I don't think this makes sense, these two. I'll see. Okay, define get underscore info self, return an f string, self.year equals year, self.make equals make, self.method equals method. We created an object called my class equals to our car class, our child class, Toyota Corolla 2020, print mycar.getInfo. Fix this inheritance mess so that when we run it, it prints 2020 Toyota Corolla. Let's go, let's go. How are you doing, Mohammed? I appreciate you joining the stream. Okay, don't just patch it. Understand what you're doing. Get to it. Okay, let me copy this. There we go. Delete these. Maybe like zoom in a bit. Zoom out a little. Delete and paste it. Okay, so indentation. To mass indent, you guys can just copy it and then hit tab. That mass indents it. Same thing should go with here. Honestly, I don't think I need a dunder init here. I mean, I need a year. Okay, method should be here. Oh. Call dunder init of superclass is missed. Can I just go with self? I can go with just self.here. Let me check the previous example. Okay, so we have an animal class. Make a sound dog class define self. So I most likely don't need this whole thing, right? Okay, might not need these. Okay, why is it showing me a red arrow mark? I mean a yellow underline. Huh. My car at parameter of car. Okay, I might need the year parameter just here. Okay, and not, I wouldn't need this whole method most likely. So year, make, model. So it can inherit the make and model. I wouldn't need a specific dunder init for it. And self.year. Okay, I gotta make an instance variable. Self.year equals to year. I have my year, so year, make and model. Okay, let me copy this, paste it. I wouldn't need this. Okay, if I were to run the command, wrong file again. Okay, now if I were to run the command, 2020 Toyota Corolla. Okay, honestly, yeah, this does look pretty good. Let me copy this. And guys, I honestly just watched like 1 or 2 tutorials on the inheritance because I didn't want to be complete like egg or something when I start the stream. So I have like a basic knowledge, but it's just like those 2 tutorials or something. Okay, what in the name of Python are you doing, Vivek? You messed up basic inheritance principles like a novice. You didn't call the parent class's dunder init from the child class. That means the make and model attributes are never set. You turned year into a parameter of get underscore info instead of a property of the car, okay? That's backwards. Year should be an attribute initialized in the child's dunder init. Okay, you're supposed to accept year when creating the object, not when calling get underscore info. Get this through your head. The child's dunder init needs to call the parent's dunder init. Oh, to set inherited attributes and handle its own attributes like year, fix it, rewrite cars so it has an dunder init that calls super.dunderInit make model. Okay, I honestly didn't learn anything about the super. Let me just say, Sensei, I honestly didn't learn about the super function or method. What does it do / mean? Question mark. Finally, a question worth asking. Super is the secret handshake between a child class and its parent class. It's like saying, hey parent, do your thing here so I can add my own twist later, okay? When you override a method in the child class like dunder init, the parent's version is hidden unless you explicitly call it, okay? Super lets you do exactly that. Call the parents methods so you don't have to rewrite the code. Maybe drink some water. I'm honestly really dehydrated. Make sure you guys are being hydrated as well. Okay, here's what it looks like in action. Okay, so we have a class called vehicle. We defined a constructor with dunder in it. It has two parameters, make and model. We added two instance variables as well. Self.make equals make, self.model equals model. And then class, the child class has a parameter of vehicles. So, okay. Then we defined a dunder in it, self, make, model year. And then we used a super method. Okay, super method dot dunder init, the parameters of the parent class, call vehicles dunder init, self dot year equals year. Without super dot dunder init, your car won't know about make and model, okay, because you skipped initializing the parents part. It's crucial when your child class wants to build on the parents initialization, or other methods won't duplicate the code. Think of super as the child knocking on the parent's door saying, I'm here, let me use your stuff and add my own. Okay, now that you understand what super does, go fix that code properly or I'll make you type this 30 times. I'll make you type this explanation 30 times. Alright, let me go here real quick. Okay, so I needed a dunder in it, so we go with define dunder init with the parents attributes. So it's make and model, and actually year as well because I wouldn't need this. I don't want to create a separate instance variable. Okay, and then I go with super. Okay, super dot my dunder init. So super dot dunder init, make and model. So these are for the parent class, okay, and then I return. Honestly, I do probably need more explanation for this. Self make model year, okay, I have those. Calls vehicles dunder init, so this calls my vehicles dunder init. Okay, and then self.year equals year. Okay, self.year equals here. Okay, and then I define a get info and return this. Let me copy this. Get here. There we go. If I run the command, it's gonna say 2020 Toyota Corolla. Alright, this actually looks perfect. Although guys, does this even look beginner friendly? I mean, it is pretty easy, but like, I don't know if I should be learning these. Okay, let me go up here and say sensei. Here, dot dot dot. And can we get more practice with this concept question mark? Finally, some code worthy of my time. This is exactly how you do it. You use super to call the parent dunder init and set the parent's attributes. Then you added your own year and the output 2020 Toyota Corolla. Perfect. Now listen up because you're not done yet. I'm going to hit you with a few more variations on this theme. We're going to play with overriding methods and calling the parents method with super inside it. Adding extra attributes in the child's class, multiple levels of inheritance, okay? Excuse me guys. Okay, here comes broken code number 2. Classes animal defined under init self-species. Self.species equals species. Define sound with a parameter of self. Return some generic sound. Okay. And then we have a child class with a parameter of our animal class. Define dunder init self species name. Self.name equals name. Define sound self. Okay, we have a sound method inside of our class. I see. Okay, we return an f string self.name. Okay, self.name meows. Whiskers equals to cat. Feline whiskers. Okay, print whiskers.sound. That's gonna print our meow, and whiskers.species is gonna get our species. Where's our species? Okay, so our species is here. Our species is going to be set to some generic sound. Okay, this overrode that, right? So it's the cat. Okay. Fix it. Okay, fix it so species gets properly. Oh my gosh, guys, I can't read. Fix it so species gets set properly by calling the parents dunder init. Name is still set in the child. Okay, the output is whiskers meows feline. Get to work. Alright, let me just copy the broken code. Go here, paste it, maybe zoom out a bit. Okay, let's see. We're missing a super function, so let's just read the code real quick. So we have a parent class called animal, a constructor that defines dunder init, a parameter of species self.species equals to species, defines sound. This is our animal class's sound, some generic sound. Okay, and then we have a child class with a parameter of animal. Okay, our parent class, and then we defined a constructor inside of our child class using the dunder init and added a name, an extra name method. Okay, so now we're missing a super. Should the super be indented here? So super. Oh, what are these? Okay, so super dunder init. Okay, and now we go with our parent class's species parameter. Okay, I don't want it to be species equals to, just species works. Okay, it's gotta be indented in that case. There we go. Let me check if I can just write species. There we go. Okay. Species, we have a name. Okay. Then define sound, self.name, meows. Okay, and we created an object called whiskers. We set it equal to cat, our child class that has a parameter of our animal that's inherited the attributes from our animal class as well. Okay, so our species is a feline and our name is whiskers. We printed whiskers.sound. Okay, whiskers.sound should give me meow, like feline or whiskers meows. And whiskers.species. So whiskers.species is okay, wait, if I run the command is feline. Oh yeah, my species is a feline. Okay, should work. And guys, these might be easy right now. It's gonna progressively get harder as I move to instructional based questions. These are broken code questions just to get me warmed up. A little bit late. How are you doing, Seashore? I appreciate you joining the stream. Okay, let me paste this. Okay, maybe drink some water. Okay, not bad, but not quite there yet, Vivek. You almost got it, but you screwed up the order of initialization in the child's dunder init. Okay, the rule of Python warfare: always call super.dunder init first before you set child specific attributes. Why? Because the parent class might set up crucial stuff your child depends on. Rewrite the dunder init like this. So super.dunder init species, okay, self.name equals name. You got the idea, but this order is non-negotiable. Fix it now or then we move on. Alright guys, and this video is supposed to be about inheritance. It feels like I'm going through the super topic, like the super functions topic, because basically I don't know what topic am I like will I be doing, or I can phrase it. Yeah, you guys probably know what I mean. Wait, actually I forgot to copy this. Let me copy this. Okay, paste it. There we go. Okay, now that's how a champ does it, Vivek. Super.dunder init species called first, okay. Then self.name set up right after clean, sharp, and battle ready. Whiskers, meows, feline. Perfect, no excuses. Time for broken code number 3. Stepping up the challenge with method overriding and using super inside an overwritten method. Okay, fix this. Class employees. Oh, since it's still writing. Hey, you just completed my setup for OAuth. Got motivation from your streaming in the nighttime. Thanks. Congratulations, Aditya. Yeah, congratulations with setting that up. And it actually means a lot that I motivated someone. Okay, that motivates me. Let's get this question. Okay, so we have a class employee and we have a constructor called dunder init. We have a name and a salary parameter. Self.name equals name, self.salary equals salary. Then we have another method called define get underscore details with a self parameter. We returned employee, self.name, salary, self.salary. We have another method called, we have a class, a child class called manager that inherits our employee classes. So that's as a parameter here. And then we defined a dunder init with a name, salary, and department parameter. Okay, this is correct. Super dunder init name salary. We have both our attributes here, and then we created an instance variable for our department parameter. Okay, and then we have another method called get underscore details. Okay, we return self.name, manager, self.department. We create an object called mgr equals manager or child class. Okay, manager's name is Alice. Alice earns $9,000 and works in the sales department. Okay, and then we print mgr.get underscore details. Okay, we get our details. Your mission: fix manager's details to include the employee salary as well. Reuse parent method using super. Output should be Alice Alice manages sales with a salary of 90,000. Go. Okay, let me copy the broken code. Get Sensei out there. Paste it here. Okay, let's see. Oh, what's wrong here? The code honestly looked pretty correct. Alice manages sales. Excuse me, guys. Okay, it should have print Alice manages sales with a salary of 9,000. Alice manages sales. Okay. Employee salary. So basically it's incomplete. These are actually pretty easy, honestly. Alice manages sales with a salary of 90,000 Alari $. Self dot salary of $90,000. If I run the command, it's going to print Alice manages sales with a salary of $90,000. Honestly, I might move on to instructional based questions. These are like way too easy. Okay, we go here, paste this and say, Sensei, can we move on to instructional based questions, question mark? These questions feels too easy, ... Guys, ignore my typos. There we go. Okay, what in the name of Python hell is this, Vivek? You can't even read the parameters, right? Manager Alice 9,000 sales means name Alice, salary 9,000, department sales, but you mixed up the order in your code. You put salary where department should be. Did I do that? Name, salary, department. It looks correct. Okay, the real error here is you didn't call the parent method with super inside get underscore details to reuse it. You are supposed to call parent underscore details equals to super dot get details. I didn't know about that. And then add your department info to it. Here's how it should look. Okay, define get details parent equals to super dot get details, but better you should refuse parent underscore details to build this string like define get details with a self parameter parent underscore details equals to super dot get details or even this parent dot details . Okay, fix that, get your parameters right, call the parent method properly or I'll force you to repeat this lesson until you bleed. When you fix it, we move on to instructional based questions. Let me just say, Sensei, a lot of eyes, ... honestly, new with the super function or method, ... I didn't know that we can use it like that. Can I get some more practice with all the different ways we can use the super function question mark? Maybe drink some water as well. And guys, let me know if like the music is like overpowering my voice or something, because I did mess with it a little yesterday. I thought the music was like too low. Alright, listen up Vivek, you're struggling with supers, so I'm gonna break it down like a boss and then throw you some practice to master it before I let you escape those training grounds. What is super really? It's a way to call methods from a parent class inside a child class, not just for dunder init, but for any method. You can use super to call the parent's constructor dunder init so you don't rewrite it. Use super to call the parent's version of a method you've overwritten. Okay, to build or reuse existing functionality instead of replacing it entirely, chain multiple levels of inheritance smoothly. How to use it? The variations: calling the parent constructor, class parent, define dunder init, self and a value, okay, a value parameter, and then an instance variable, self.value equals to value, class child parent. So this is a child class that inherited my parent class's attributes. I defined a dunder init, self, value, extra, and then I use my super function dunder init with the parameter of value. Okay, calls parents dunder init, self.extra equals to extra, calling a parent method from an old written method, class parent define greet with a parameter of self, return hello, okay. Child, okay, so we have a child class that inherited our parent class, define greet. Parent underscore greeting equals to super.greet, calls parents greet, okay, return parent greeting plus and welcome. Okay, multiple inheritance and method resolution, order MRO, multiple inheritance and method resolution. Okay, Python uses MRO, multiple inheritance and method resolution, order, okay. Python uses MRO to decide which parent's method to call when you have multiple parents. Super respects this order. Python uses MRO to decide which parent's method to call when you have multiple parents. I see. Okay, your practice, soldier. Fix these broken pieces using super correctly. Broken code number 1. Class A define hello, self return hello from A. Class A with the parameter of B, so this is a child class, define hello, return hello from B. Okay. Class C which inherits class B. Okay. Class C which inherits class B traits, define hello, return hello from C, and plus a hello self. Don't call a hello directly. Okay. And then I create an object called C with a pair of parentheses, print C.hello. Okay, fix it so that C uses super to call B's hello method instead of directly calling a.hello self. Output should be hello from C and hello from B. Get that done first, then I'll give you more variations to crush. No slacking or you'll be writing this explanation 30 times. Okay, that just twisted my brains in all sorts of ways. Alright, I probably gotta hydrate a bit to process that. Okay, let's see. Let me copy that, paste it here. Alright, now let's try to brainstorm. Okay, so I have a class A, define hello. Okay, that's my parent class. My class B inherits my class A's attributes. Okay, but it doesn't have a parameter of its own, so I will use the super hello. I just need super dot dunder init. Okay, I need super dot dunder init without any parameters because my class A doesn't have any parameters. And I'll need my super dot dunder init here as well. Okay, return hello from C and A, so my return hello from A. So return from hello C and return hello from A. If I run the command hello from C and hello from A, let's check if that's the outcome I needed. Hello from C and hello from B. Okay, I need hello from C and hello from B. B inherits the attributes from A. What if I change this to B? Hello from C and hello from B. This is exactly what I needed. Did I understand much? Honestly, no. Will I get more practice? I mean, of course. Let me copy this, get Sensei up here, paste it. Let me say, Sensei, I fixed it, but I don't have enough practice. ... Can we get a few, or can we do a few instruction-based codes? Question mark. Guys, ignore my typos. What are you doing, Vivek? Super.dunder init has nothing to do with this. You're supposed to call super.hello, not super.dunder init. The hello method, okay. Not super. Excuse me, guys, not super.dunder init in the hello method. And you can't call b.hello self. Excuse me, guys, you can call b.hello self directly. Okay, directly like that, that defeats the purpose of super. Okay, here's what you need to do. Class CB define hello self, return hello from C, and plus super.hello. Okay. Super.hello calls B's hello respecting the method resolution order. Now you ask for instruction-based codes. Fine, instruction-based codes number 1. Alright, let me go up and say, never mind Sensei. Guys, ignore my typos. Never mind Sensei. ... I actually don't understand it at all. ... I honestly don't even know how to ask a question to answer my questions. Question mark. Can we just go from scratch and work our way up? Okay, let's see. That's not a sign of weakness, Vivek. That's where real learning begins. If you're lost in the dark, it'll be the torch that lights the path, but you're going to walk it, okay? We're going back to the absolute basics of inheritance. No fluff, no shortcuts, just steady steps. I'll explain everything from scratch, slowly, clearly, and with examples that hit like a train. We'll build your understanding one brick at a time, then do broken code, then instructional-based problems. Ready to dive deep? Let's start with what is a class, what is an object, then what does it mean to inherit? Classes are blueprints. Objects are the instances, okay? Inheritance means a class, child, gets features from another class, parent, okay, I get that. Here's a baby step example to start. Class animal defines speak self. Return animal speaks. Okay. Class dog, this is the child class, it inherits our animal class's attributes. Pass as a placeholder. Okay, D equals to dog, so we created an object called D, set it equal to dog. Print D.speak. Okay, what do you think this prints? Tell me what you think. Tell me what you think happens here before I hit you with more. Okay, so let's think what this could print. So we created an object of our dog. Since our dog is a child class and it inherits the attributes from our parent class animal, it's going to return the animal.speaks. So animal speaks, right? Let me just say, Sensei, this should return animal speaks. because since it doesn't have any codes in its function, is that how we say it? Since it doesn't have any codes in its method, it's going to return what it inherited from the animal class which means it would return the return statement in our speak method. There we go. Maybe drink some water as well. Finally, it responds and makes me proud. Yes, you're absolutely right. Since dog doesn't have its own speak method, it inherits the one from animal. So calling d.speak runs animal speak method and returns animal speaks. You're starting to get the concept of inheritance. A child class automatically gets all methods and attributes of its parent unless it overrides them. Okay. Now let's push it a little further. Add a speak method to dog that returns dog barks, and then test what d.speak prints. Now write the code for that and show me the output. Okay, let me just copy this code, get sensei here, delete, paste this. Alright. So we have a class animal.speak. Okay, I need to add a bark method. Before that, let me add a super method. So super okay, super. Honestly, I might not need a super here. Let me actually define a method called add a speak method to dog. So let me define a speak method, okay, to dog that returns dog barks, and I will return, excuse me guys, return, okay, just dog barks. So dog barks. So I created an object and used my dog child class, and then I print d.speak. So it goes with this. If I were to run the command, it's going to say dog barks. Meanwhile, if I didn't have my this method here, instead I had a pass placeholder and run the command, it's going to say animal speaks. Okay, perfect. Control Shift C, Control C. Guys, did I like mess up? No way, I gotta write that again. Let me paste this. There we go. Let me define a speak with a self parameter. Return dog barks. Okay, perfect. Let me keep this to barks. Alright, let me copy this. Get sensei up here and paste it. And guys, let me know if the music is overpowering my voice. I did do a few tweaks yesterday with the music, but since I have my headphones on, I'm listening. If I'm audible or not, I can't say if the music is good, because I'm listening to my voice plus the OBS's music plus the music in my video. Okay, that's the code I want to see, Vivek. d.speak now prints dog barks because you overrided. Okay, because you overrided the parent speak method in the child class. This is method overriding. The child class replaces the parent's behavior with its own. Okay, with its own when it defines a method with the same name. You're doing well. Next step, modify your dog class's speak method so it first calls the parent speak method and then adds and also barks. Okay, the output of d.speak should be animal speaks and also dog barks. Write that code now. Okay, this is helpful so far. It is helpful. I can't click this, but okay. Okay, next step, modify your dog class speak. Speak method. So it first calls the parent speak method and then adds and also barks. Animal speaks and dog barks. Okay. Let me get sensei up there. So first I gotta get my animal speaks. Okay, so inherited that. Let me go with my animal classes speak first. So speak or super dot speak. That doesn't work. Okay, so first it should most likely inherit this, so might go with, I don't know, I honestly never did questions like these. Might get a reference to this question first so I can understand how to even solve questions like these. Alright, let me just space this and say, Sensei, I never did questions like these, so can you show me the format question mark? How do I use both the child class and the parent class together in the child class question mark? Guys, ignore my typos. Okay, maybe drink some water as well. Make sure that you guys are being hydrated as well. Okay, listen up a bit, you're almost there, but not quite. You asked, how do you use both the child class and the parent class methods together inside the child's method? This is the golden moment where super shines. Okay, here's the format you want inside your child class method to call the parent's version. Okay, class dog animal define speak self. Okay, parent speak equals super.speak calls, oh okay, so variable, I see, calls parent speak return parent speak plus also barks explanation. Your capture is, you capture its output in parent underscore speak, then you add whatever extra message the child needs and returns the full string So your complete code will look like this. Class animal defines speak self, return animal speaks. Class dog with a parameter of animal defines speak self, parent speaks equals to super.speak or parent speak. Return parent speak plus and also barks. Okay. When you run it, you get animal speaks and also barks. Now it's your turn. Write this code yourself. Send it to me and we'll keep sharpening your inheritance mastery. Okay. Let me get Sensei up here and actually check if I'm audible. Okay, perfect. Alright, so I'll have to add a parent speak as well. Pretty sure the speak goes before anything else, so parent underscore speaks equals to, let's see, super dot speak. Did my super have like pair of parentheses dot speak? Okay, what if there wasn't a pair of parentheses? Okay, this is important. I should ask why. Okay, now if I run the command, but before that, let me go with parent. Do I need to like go with return parent underscore speak plus and also so I need to copy this, paste it here, Okay, so parent speaks and also barks. Okay, parent speaks and also barks. And also barks. It should return. Oh, so my self.speak method comes before this. These need to be indented. Okay, I got a few questions to ask. Okay, if I wonder if I was going to say animal speaks and also barks, I got multiple questions to ask. Okay, let me paste this, add a bunch of spaces and say sensei ... So I have a few questions to ask! Exclamation. So the first question is that is the parentheses in my super necessary ? Because correct me if I'm wrong, when I use the dunder init instructor, actually constructor, there you go. When I use the dunder init constructor, I don't use the parentheses in my super ? And also, why does my parent underscore speak equals to super parentheses dot speak parentheses come under my method? I thought that that's the first thing that I should write after making a child, actually after creating a child class, creating a child class ... Okay, and ignore my typos. Let me just fix a bunch of these typos. Use the okay, that's good. Okay, that's a lot to unpack, Vivek, but you're asking the right question, so listen closely. Is the parentheses in super necessary? Yes, it is. Super is a function in Python 3 that returns a temporary object, the super object, which allows you to call methods from the parent class. To actually call a method like speak, you first get the super object by writing super, okay, then call the method super.speak. In other words, super by itself is just the function name, no method call yet. Super calls the function and returns the super object. Super.speak calls the speak method on that super object. For example, the parent speak. Okay, super by itself is just function name, no method called yet. Oh, I see. Super with parentheses calls the function and returns the super object. Okay, super.speak calls the speak method on that super object, the parent speak. Okay, why do you call super inside the method and not the top of the class? Why do you call super inside the method, not at the top of the class? Because super is used to call a method on the parent class at runtime inside your child's method. Because super is used to call a method on the parent class at running time. Oh, I see. You don't call super right after defining the child class, because super only makes sense when you want to call a parent method from within a child method. Okay, it needs the context of the method call to work properly. In your dog.speak method, you want to use the parent speak, so you call super.speak inside that method, not outside. If you call super outside a method, it wouldn't know which method you want to call. Quick analogy, imagine super as your phone call to your parent class, okay? You only make the call when you need to talk. Imagine super as your phone call to your parent class. I see. You can only make the call when you need to talk. Inside the method. I see. You don't call your parent immediately when you move out of the house. Class definition. Okay, in summary, we have a child class dog which inherited our animal classes, methods and attributes, defines speak self. Parents underscore speak equals super.speak. This is a method where you want to reuse parents' behavior. Make the call to parents method here, okay, return parent plus also barks. Keep this in mind or you keep messing up super until I make you type this 30 times. Okay, now if you're ready, send me that fixed code or ask another question. Okay, I see. I definitely need more practice with this, but I'm actually trying to get a grasp of it. I actually thought inheritance didn't include super everything. Like if I like a quick shameless plug, maybe not. If I like go to my Discord server, right here, there we go. Go to moderator only. I thought super was a separate topic of its own. It wouldn't come under inheritance. I was just supposed to inheritance this live and next live multiple inheritance, then the super. But I'm pretty sure these three they're together or something. Alright, what are we? Okay, let me just go here. Copy this. Wait, didn't I already copy this? Get here, paste it, send it. Maybe drink some water. Guys, I'm honestly using ChatGPT 5. It like updated it or something. That's the reason ChatGPT sensor is a little different. It gives me pretty quick answers for some reason. That prints animal speaks and also barks. You finally got this down. Your dog class calls the parent speak method with super.speak. Okay, grab that string, then adds its own flavor. Now your brain is cooking. Inheritance on a high flame. Next level, want me to throw you some instruction-based tasks to put this mastery to the test? Honestly, I might just go with some instruction-based questions. Sensei, can I get an instruction-based question? Guys, ignore my typos. Okay, here comes your instruction-based challenge, Vivek. No excuses, no shortcuts. Write two classes, class person. So we have a class called person. Has a constructor of dunder init method that has a constructor method of dunder init that takes name and age and set them as instance variables. Has a method introduced that returns hi, I'm name and I'm age years old. Class employees, so another class called employee which inherits from the person class, okay, and it has a dunder init constructor method as well that takes name, age and employee ID. Use super to initialize name and age, okay, set employee underscore ID as an instance variable, overrides introduced to add. My employee ID is employee ID to the string returned by the parents introduce method. Okay, so the parents introduce method is this, I see. Finally, create an instance of employee named emp with your own values and print emp.introduce. Get that done, soldier. Alright, sounds pretty easy. I hope it's easier to even write it out. Okay, so I gotta create a class called person. Okay. Aricolon. Okay, has and dunder init. So I created a parents class called the person. Let me add a dunder init constructor method. So dunder init, okay, that takes name and age and sets them as instance variables. So I'll add two parameters of name and age, okay, and set them as instance variables. So self.name equals to name and self.age equals to age. Alright, has a method called introduce that returns hi, I'm name and I'm 8 years old. Okay, so I define a introduce method. Introduce. Alright, so I will return an f string that says hi. I'm myself.name, I'm name, okay, and I am self.age, I'm name and age years old. Full stop. Alright, then create another class called employee, which inherits from the person parent class. So let me create a class called employee, okay, this with a parameter of my person. Copy that, paste it here. Okay, now my employee class inherits the traits of my parent class, my person class. Has a dunder init method that takes name, age, and employee ID. Uses super to initialize name and age. Honestly, guys, I might just refill my bottle real quick. Yeah, I might just say that because I want to use the restroom really bad. I couldn't use it for a while. Give me like 5 minutes. I'll be right back. Alright, mic testing, mic testing. Okay, so guys, I just went to the restroom, but then I realized I gotta go to Walgreens real quick for getting some of my pictures or something. But I'm gonna be closing the stream for now, but I will be opening it. I'm gonna start another stream, and I guess around 3 minutes to an hour. It's really sad, but it's actually kind of important. So I guess I'll start the stream in a bit. This is kind of disappointing. I apologize for the inconvenience, but I'll be right back real quick.